All right, welcome back, everybody. We are going to start chapter 8, which is pretty much our last chapter that we're going to do for the semester. We're going to dabble a little bit into chapter 9 if we have time, but this is the last full chapter that we're going to talk about. So in 8.1, we're going to talk a little bit more about the square root property. Last time we talked about kind of like raising an equation to the power of 2, so that way, or the power of 3, using the power rule to, untrap a variable from a radical. Now we're going to use the, zero factor property, which we've done already since it's a review. So we're going to have to factor in all that good stuff. Solve quadratic equations in the form of ax plus b squared. This is called, vertex, more or less vertex form of a quadratic, which is pretty nice. And then we are going to solve equations by completing the square. Now, just so you know, this is my least favorite method of solving a quadratic. There are pretty much three unique methods that we can use. One is the zero factor property. That only works if it's factorable. You have the quadratic formula, which we'll learn in the next section. That's number 2. So if you can't factor it, my next go-to is the quadratic formula. And then there's this last one as a last resort. If I absolutely have to, I will complete the square because it's pretty restrictive. It becomes pretty tedious if things don't line up as well as we want them to, and I'll explain a little bit about that once we get there. And then we'll solve quadratics with non-real numbers. So finally, we're going to talk about complex numbers, the imaginary number system in this section. I know that you've all been at the edge of your seats all semester long, waiting to talk about complex numbers, and here's your opportunity to finally discuss them with me. All right, so quadratic equation in terms of x can be written as ax squared plus bx plus c is equal to 0. Remember, this is standard form of a quadratic equation, and the reason why it's equal to 0 is because, of course, this is your y part, and we want the y value to be 0, so we can figure out where these quadratics cross the x-axis, because, of course, the x-axis is when the y value is 0, okay? So let us continue. All right, so again, this says the quadratic equation is a second degree equation. That is an equation with a squared variable term and no terms greater than of a greater degree. This will also indicate that we will have at most 2 solutions to the equation. So if you have a degree 3 equation, you could have up to 3 solutions. If you have a degree 10 equation, you could have up to 10 solutions. So we'll focus on solving these degree 2 equations, these quadratic equations, so that way we don't have to worry about getting 10 or 15 solutions, something like that. All right, so again, here's a review of the zero factor property. This says that in order for a times b to be equal to 0, a has to be 0 or b has to be 0, or both. They could be both be 0 if you wanted to, but then they wouldn't be separate variables. It'd be a and b, but that's neither here nor there. So either one of these guys has to be 0 in order for the equation to be equal to 0. All right, so let's take a look at this. Remember, we want it to be equal to 0, so what we're going to do first is we're going to add 1 to both sides, and that's going to give us an equation of 2x squared minus 3x plus 1 is equal to 0. And then we're going to factor this to see where that takes us. So if you factor this out using the product sum method, you'll see that the product has to be 2 and the sum needs to be -3. And the only way that that happens is if both of these factors are negative, because a negative times a negative is a positive, and then of course a negative plus a negative will still be a negative. So our factors of 2 that add up to -3 are of course -2 and -1. So we will put this as -1 and -2 over here. It doesn't matter which order that you put it in. But remember, our a value, the way that I factor, since my a value is 2, I'm going to scale these back down, and that will give me, again, this doesn't work here. This first 1 divided by 2 is a fraction. So what happens, this 2 goes out front, and then you end up with 2x minus 1. And then this does work, and you get x minus 1 equals 0. So that's your quick review of factoring. I probably won't go through the motions from here on out. I'll probably just factor it, and then hopefully you can factor it as well. And of course, we need to solve this. The shortcut is, of course, to say the opposite divided by. So we get x equals 1 here, and then opposite divided by. So we're going to get x equals 1/2 there. So those are our two solutions. We don't have to worry about checking them because we didn't square both sides. We didn't use the power rule to get any of those extraneous solutions that we got in the last section. All right. So those are our two solutions to example 1. All right, so if x and k are complex numbers and x squared equals k, then x equals the square root of k, or x equals the negative square root of k. All right, so essentially what's going on with this is that, this is the square root property. They're trying to get you to understand what's going on here. But what I'm going to show you now is a very simple definition, okay? And the definition is this, that the square root of I, okay? The square root of I, the square root of -1, sorry about that. Square root of -1 is equal to I. At this point in this course, we have not been able to take the square root of a negative number. We can't take the 4th root of a negative number. We can't take the 6th root of a negative number. Remember, when your index is even, you cannot complete the operation. You have to write that it's a non-real number. Well, since it's a non-real number, it means it's an imaginary number, a complex number. So the I here indicates that we are going into the imaginary number system, the complex number system, okay? And this is helpful. So now that we can take the square root of, let's say, -9. Back in the day, in previous chapters, we have not been able to do this. We had to say that this result was non-real. But now we're able to do this by using the same principles that we used in chapter 7, breaking this up so that it is the square root of 9 times the square root of -1. And you can see that the square root of 9 is, of course, 3. And then the square root of -1 using this definition is I. So the result here of taking the square root of -9 is now going to be 3I. Okay, so this is going to be an important thing for us to recognize, and this is telling us here that if you have some equation that is squared, when you take the square root of both sides, you are getting both the positive and negative version of that result. So let me talk to you a little bit about this definition here before we move on. So let's go off to the side. So what this is saying is basically, we'll use some numbers here to kind of make sense of what's going on here. So x squared is equal to, 16. We'll make it nice, easy numbers here. Well, what we're trying to do is we're trying to figure out the values for x that if you square them, you're going to get positive 16, right? The square root property says we just have to take the square root of both sides to figure out what x is. So we do that, and most students say x is equal to 4 because we know that the square root of 16 is 4. But the reality is, if you square 4, you definitely get 16. But you could also square -4 and you would still get 16. And that is why you get positive and negative results here. So it starts when you have an equation that is equal to some squared result. And in order to solve for the variable in question, you take the square root of both sides. That's when you get the positive and negative version of these results here. So it's important to note that. If you're just taking the square root of 81, that result is 9. Not positive and -9, it is 9. It's what happens when you have x squared is equal to 81. In order to solve for x, you have to take the square root of both sides. This is where you will get positive and -9 as a result, right? So you've got to be able to distinguish between the two ideas, right? Okie dokie, so let's take a look at this. So again, we will take the square root of both sides because we're trying to figure out what m is, and that gives us m is equal to positive and negative 8. Easy peasy lemon squeeze. Over here, we have 3x squared. Add 54 to both sides is equal to 54. Divide by 3, and you get x squared is equal to let's see, that's going to be what, 18? 18, perfect. So this is going to give us 18 here, and then we take the square root of both sides, and we get x is equal to positive, negative. Again, you need to make sure that you simplify this radical. It's currently not simplified. This is going to be positive, negative, 3 square roots of 2, using the idea, and I'll do it one more time since we're taking a trip down memory lane here. This is going to be square root of 9 times the square root of 2. Square root of 9 is 3, and then the square root of 2 comes along for the ride. So that's where I got 3 radical 2 from. And of course, it's positive, negative, all right, because we had to take the square root of both sides. All right, so an expert marksman can hold a silver dollar at his forehead, drop it, draw his gun, and shoot the coin as it passes waist level. If the coin falls about 4 feet, use the formula, this is the distance formula here, to find the time that elapses between dropping of the coin and the shot. Right? So this is pretty impressive here, right? So this says the distance is going to be 4 feet. So we're going to just substitute 4 in for D because that's how far the coin is falling, is equal to 16t squared. And now we've got to, divide by 16, divide by 16. That'll give us 1/4 is equal to t squared. And then you take the square root of both sides. And that's going to give us 1/2 is equal to t. And I know technically it's supposed to be positive, negative, right? Because we just went over that whole spiel about how when you're taking the square root of both sides, you need the positive and negative version. But this is time, right? So within the context of this problem, you do not care about this negative part because this is time. You can't go back in time. So it takes the marksman about a half a second to drop the coin, reach for his gun, and shoot the silver dollar as it passes its waist. So pretty neat. All right, so this one looks like it's going to be a lot more complicated because it's got a whole lot of extra stuff going on. It's not just an x that you're squaring here, it's this x minus 3, but that doesn't really bother us too much, or at least it shouldn't, because remember, we could, if we wanted to, use that u substitution here if we felt comfortable doing that. Kind of a waste of time. I think it's probably more work than what it's worth, but this would be u squared equals 16, and then we would just rock and roll from there. So don't get too concerned that there's a binomial inside here. You can still take the square root of both sides, and you end up getting x minus 3, because the square root and the square cancel each other out, is equal to positive negative 4, because the square root of 16 is positive and negative 4 here. And what's going on here now is we have two equations, two different equations. We have one where it's x minus 3 is equal to 4, and we have another one that says it's x minus 3 is equal to negative 4. So this is where we break this up and solve both of these equations. X minus 3 is equal to 4, and x minus 3 is equal to negative 4. We've got to sort of divide and conquer these two solutions here. Remember, this is a degree 2 equation, so we're expecting to get at most 2 solutions, and in this case, we're actually getting 2 solutions. So we're going to add 3, x equals 7, and then over here, we're going to add 3 again, obviously, and that's going to give us x equals negative 1. And you could always check these if you wanted to make sure that everything is legit. So you can take the 7 minus 3 is 4, 4 squared is 16, perfect. Negative 1 minus 3 is negative 4, negative 4 squared is still 16. So both of these solutions check out, which is great. All right, so let's take a look at this one now. Again, same sort of deal. we are going to take the square root of both sides again. And right off the bat, we recognize that this square root of 2 is not a perfect square, right? We're not going to be able to figure out what that value is. So this is going to be 3x plus 1 is equal to, I'm going to leave the square root of 2 there, all right? MyMathLab will be very specific as to what it wants from you. So it will either say round your answer to the nearest decimal, or a tenth of a decimal, or hundredth place, whatever it tells you to do, which means you're allowed to take the square root of 2 to get the decimal value, okay? If you don't see something like that, then they probably want you to write the answer in terms of the expression that you're going to get here, all right? So this is positive, negative, square root of 2, which means we have two equations here. One where it's 3x plus 1 equals positive square root of 2, and the other one is 3x plus 1 where it's equal to the negative square root of 2. And then we start solving this equation as if we were solving any old regular equation with two variables, because we just can't do anything with this. We can't simplify that unless they tell us that we are allowed to write the decimal value. But I'm going to assume that we can't. So let's say we subtract 1 to both sides, which gives us 3x is equal to square root of 2 minus 1. Remember, we can't combine these because in order to combine radicals through addition and subtraction, you have to have the same index and the same radicand. This is not even a radical, so we can't combine that. And then last but not least, we'll divide by 3, and that gives us x is equal to the square root of 2 minus 1 all over 3. So that's our first answer, and this is, again, going to be something very similar. So we'll get 3x is equal to negative radical 2 minus 1, and then we're going to divide by 3, and we get x equals negative square root of 2 minus 1 over 3. And that gives us our second answer. You could, if you really felt compelled, to substitute these values in. If you wanted to put the decimal in and just put in as many decimals as you wanted to try and figure out if you got 2 as an answer. Probably not worth it. I wouldn't do it if I were you. All right, just trust in the fact that these are the solutions that you are getting. All right, so this is our next problem, which is now completing the square. Okay, so we call this process completing the square because that's pretty much what we're doing, is we're creating a perfect square trinomial, which we talked about back in chapter 5. So what we're going to do is we're going to make sure that I'll write the steps over here, and hopefully we can follow those steps. Step 1 is going to be to make sure that the equation is in the form of ax squared plus bx is equal to c. And I'll put c in sort of quotes because it'll really be the opposite of c. So in this case, we actually don't want the equation equal to 0. We would prefer it to be equal to whatever the constant value, c for constant, okay? Once you have that, we are going to take half of b. All right, so whatever your b is, take half of it. Step 3 will be to square the results of step 2, okay? Step 4 will be to add the results of step 3 to both sides of the equation. All right, step 5, once we do that, we are going to factor the perfect square trinomial. All right, we're going to factor the perfect square trinomial that we created. So the whole process of doing this is we've created this perfect square trinomial, in this case on the left-hand side of this equation. All right, so we're going to factor that. So that's going to look like this. It's going to be x plus or minus some value squared. So that's what that's going to look like, all right, this perfect square trinomial. And spoiler alert, this number right here is going to be whatever result you got for doing half of b. That's the number that's going to go inside here, all right? So there's your spoiler. Step 6 is we are going to take the square root of both sides of the equation. And then last but not least, we are going to solve both equations that we got. So remember, when we take the square root of both sides, we are getting to the positive and negative result. So that's what we've got to do. We've got to solve both of the equations. Okay, so let's go ahead and do this. So we are going to make sure that this is in the correct form of this ax squared plus bx is equal to c. This is currently not in that correct form, so I'll do that. So x squared minus 2x is equal to positive 10. Adding 10 to both sides, we get what we want. So step 1, we're going to take half of b. So negative 2 divided by 2 is negative 1. All right, so actually this is step 2, sorry. Step 2. Step 3 says we're going to square that result. So square the result of step 2. So I'm going to square negative 1 and I'm going to get positive 1. Step 4 says add this 1 to both sides of this equation that we've created up here. So that's going to give us x squared minus 2x plus 1 is equal to 11. Adding 1 over here, adding 1 to 10 gives you 11. Factor the perfect square trinomial that we've just created. This left-hand side is 100% a perfect square trinomial. We created it, okay? So step 5 is going to be x minus 1 squared is equal to 11. Remember, the trick is whatever you get here for this result, that's the number that you're going to put inside there. That's not a plus. That was just a scribble. Step 6. Square root both sides, so that's going to give us x minus 1 is equal to positive negative square roots of 11. And now step 7 says let's go ahead and solve both of these equations. So positive radical 11 and x minus 1 equals negative radical 11. And then we get our answers. So we get x equals 11 square root of 11 plus 1. X equals negative square root of 11 plus 1. Those are our two answers when we're completing the square. So normally students have to memorize this, right? But you guys are, hopefully doing the honor system and you are also memorizing it. But since you don't have sort of big brother kind of looking over your shoulder, my assumption is that you will probably be looking at your notes while you're taking the test. But if you're not, and you've memorized this or you already knew it, good for you. That is wonderful. Lots of fun stuff with this completing the square if you're into it. Now, remember I said, this is my last resort. As you can clearly see, this is why it's my last resort. There's 7 freaking steps to this thing. It takes a while to do. And also, if you don't have the perfect situation, this becomes a much more difficult process to complete, even more difficult than what we just saw. Here are the things that make this more difficult. If your A value is not 1, your A value is not 1, this becomes much more difficult to do. If your B value is not an even number, this becomes more difficult to do. Because again, in step 2, you take half of b. So if this is a 7 over here and you're taking half of it, you're going to get a fraction over there. And then what are you going to do with that fraction? You're going to square it, which is going to give you a different fraction. And then what are you going to do with that fraction? You're going to add it to both sides, which means you need to have a common denominator to be able to add it. So all hell breaks loose when your A value is not 1 and your B value is 9. So usually for me, it is an absolute last resort. I only do it if I have to do it, or I'm trying to get this in vertex form, which we'll talk about later on when we start graphing quadratics. Okay. So these are the steps, and let's take a look at this. So I'll probably just start this because again, our A value is not 1, our B value is, I'm sorry, A value is 1, but our B value is not very friendly, but we'll do it anyway. So step 1 says we are going to get this in the correct form of x squared plus 3x is equal to 1. And then I'm going to take half of b, so this is step 1. Step 2, take half of b, so 3 divided by 2 is still 3 over 2. Step 3, remember, keep this result in mind. You're going to use it again. Step 3 is to square the results, so I'm going to take 3 halves and square it, which is going to give me 9 over 4. Step 4 says I'm going to add this to both sides, so that's going to be x squared plus 3x plus 9 fourths is equal to, and what I'm going to do here is I'm going to just write this as 4 fourths, right? So that way I know that when I add this 9 fourths to both sides, it's going to give me 13 fourths. So remember, when you add these fractions, you need to have a common denominator, so it's just helpful to have 4 fourths over here instead of 1. Step 5, factor the perfect square trinomial. So this is going to be x plus 3 halves. Remember, we talked about how whatever this results in step 2, you're going to see it again, you're going to use it again, and there she is. And it's squared is equal to 13 fourths. Now we're going to take the square root of both sides. That's step 6, which is going to give you x plus 3 halves is equal to positive negative square root of 13 over 2. Because I just took the square root of top and bottom, I was able to take the square root of the 4 pretty easily. And now, last but not least, I have to split this up into 2 separate equations. X plus 3 halves is equal to square root of 13 over 2. You have x plus 3 halves is equal to negative square root of 13 over 2. I said I wasn't going to do everything single step, but we're so close now, I might as well finish it up. So this will give us x is equal to square root of 13 minus 3 all over 2. And this will give us x is equal to negative square root of 13 minus 3 all over 2. So, like I said, becomes much more problematic when your A value is not 1 and your B value is. It becomes even harder when your A value is not 1. You end up having to factor that out regardless if it's factorable or not, and then divide it to both sides. So it becomes a real big problem when your A value is not 1. So I'll just show you quickly what would happen here when your A value is not 1. All right, so we're going to add 2 to both sides to get 3x squared plus 6x is equal to 2. And what you need to do now is factor a 3 out from both of these. This is really convenient, the fact that 6 has a factor of 3, but it doesn't always, right? So this could be a 10 for all we know, and we would still have to factor that 3 out because our A value is not equal to 1. So we factor our 3 out, and that gives us x squared plus 2x is equal to 2. And then we divide by 3, and that gives us x squared plus 2x is equal to 2/3. And now we're in slightly better shape because at least my b value here is an even number. So when I square it, I don't have to square a fraction. But when you add it to both sides, you still have to worry about this common denominator over here. So if you want, I guess I could start this real quick, and I will not actually finish this one out to its entirety. And I mean it this time. So let's just go ahead and take half of b. So step 2, take half of b. So 2 divided by 2 is 1. Step 3 is to square that result. So 1 squared is 1. And then Step 4 is to add that to both sides. So you get x squared plus 2x plus 1 is equal to 5 thirds. Because remember, you're really adding 3/3 to both sides, which is where the 5/3 came from. And then this is x plus 1 squared is equal to 5 thirds. And then you start taking the square root of both sides, which again becomes more problem. You know what? I'll just do this last step here, and then I won't solve it. Take the square root of both sides, so you get x plus 1 equals positive negative square root of 5 thirds. Remember, you cannot leave a radical in the denominator. You need to simplify this. So this becomes positive negative square root of 15 over 3. Remember, let's go off to the side. Last chapter, in order to simplify this, you had to multiply by the form, by the form of 1 that we needed, which was radical 3 over radical 3. And that is what gave us the square root of 15 in the numerator, and that is what gave us 3 in the denominator. So you need to be extra careful and make sure that you're keeping track of all those rules that we've learned over the course of the semester, especially the ones that deal with radicals that we learned last chapter, in all the conditions of a simplified radical, which means no radicals in the denominator. All right, so let's take a look at this one. So we are going to take the square root of both sides here, just like we did before. And the big news here is that we finally have a negative over here. So our result when we take the square root of both sides is going to give us x is equal to positive negative radical 17. And then you can either put I out here or you can put I out front. It doesn't really matter. I like to put it in the front here just so it doesn't look like it's underneath the square root, because it's not. All right, the square root of I is something totally different. So we'll cross that bridge in trig and in pre-calculus for those of you who are heading in that direction. All right, so again, same thing here. Take the square root of both sides. So that's going to give us x plus 5 here. And this will give us positive negative 10i. So this time the square root of 100. This is a perfect square, so we were able to actually do the square root of 100. And then I is out here as well. And then we get two results. Again, x equals 10i minus 5. And x equals negative 10i minus 5. So this was still a degree 2 equation, which means we're still expecting to get at most 2 solutions. And we ended up getting 2 solutions. We still got 2 solutions. They're just non-real. They're complex solutions. So don't think that, if you have this negative here, if it's not factorable, that there's not going to be a solution. There aren't going to be roots. There are 2 roots here. They're just non-real. All right, so the quadratic formula will be the next thing that we talk about. And again, the hardest thing about the quadratic formula is memorizing it. So for those of you who are using the honor system and you are not checking your notes while taking tests and things like that, or using Google, then you should memorize this. It's pretty neat formula. Most of you have some vague recollection of it. Anyway, it's that whole x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So that's the quadratic formula. We'll talk a little bit about this, and I think that'll wrap us up for today. All right, so here is our quadratic formula. Again, this is plan B for me. If I can't factor it and there's no other way for me to figure out what those roots are, I will use the quadratic formula, because it's pretty much just plug and chug. Like, once you know the quadratic formula, you just plug in your ABC everywhere you need to, and you figure out what your answer for x is. So sometimes you get 2 of them, right? So you have this plus or minus business going on, all right? So let's continue. So we are going to solve this using the quadratic formula, right? And this says we're going to have rational solutions, which means this was factorable. anytime we get rational solutions, it means your original quadratic was factorable. So factors of negative 12 that add up to negative 11 are negative 12 and 1. So this is factorable. We could figure out what this is right now if we wanted to, but let's just use the quadratic formula to see what happens. All right. So we have x equals the opposite of b plus or minus the square root of b squared minus 4 lives there, a c over 2a. So I've just substituted all my ABCs. Some students like to have like their ABCs written up to the side here. So my A is 4, my B is negative 11, and my C is negative 3. So if that helps you, go nuts. But yeah, they kind of color coded it for me, so it made things a little bit easier to keep track of everything. So let's start evaluating. So let's do 11 plus or minus the square root of 121 minus, this is going to be negative 16 times negative 3 is going to be plus 48 over 8. And that will give us 11 plus or minus the square root of 169 over 8. And 169 is a perfect square, which is no shock to me since I was expecting to get rational solutions anyway. So this is going to be 11 plus or minus 13 over 8. And now we split it up. So this is going to be 11 plus 13 over 8. And this is going to be 11 minus 13 over 8. And we'll figure out what our answers are. So this is going to be 24 over 8 is 3. And this is going to be negative 2 over 8, which is negative 1 fourth. Sorry, brain fart there. There we go. So those are our solutions using the quadratic formula. If we factored this, we would still get the same result that we were looking for. So I'll show you that real quick. So this is going to be x. I already said that it was negative 12 and positive 1 is equal to 0. Remember our a value is 4, so we're going to scale these back down. So this is going to be x minus 3. 4x plus 1 equals 0. And then we use our trick of saying x equals 3, opposite divided by, opposite divided by. X equals negative 1, 4, which is the exact same answers I got here. And it was a heck of a lot easier to get them by factoring because I'm so much better at factoring than I am at, evaluating these results and breaking them down and breaking them down and breaking them down. I think it's just really tedious. So I always check to see if I can factor it. That's always my first go-to. I try to factor it. If I can't, I'll use the quadratic formula, unless somebody tells me I have to complete the square. That's pretty much how I go about solving these quadratics. That's the process. All right, so let's do this one. First thing that we're going to want to do is get it in the correct form. This has got to be equal to 0, and it's currently not, so we need to make sure that it's equal to 0. So this is going to be 2x squared plus 14x plus 19 is equal to, sorry, should be minus, is equal to 0 when you subtract 14x to both sides. So our a is 2, our b is negative 14, and our C is 19. All right, so let's go ahead and start to substitute. So x is equal to the opposite of b plus or minus the square root of b squared minus 4a, 4a C over 2 and A. All right, so let me just double check to make sure that I substituted everything correctly. So the last thing that you want to do is make an error in substitution. There's lots of other harder things that we need to do here, so let's not make a mistake with substitution. So x equals 14 plus or minus the square root of 196. And this is going to be 4 times 2 times 19 is, let's see, 4 is 152. So this would be minus 152. And then this is going to be 4. So x equals 14 plus or minus square root of 196 minus 152 is going to be 44 over 4. And this is definitely not a perfect square, but there is a perfect square factor in here. So we've got to take that out. So we get x equals 14 plus or minus 2 radical 11 over 4. And we're really, really close to being done. All we have to do is kind of split this up and then simplify these factors of 2 that are going on here. So we'll have 2 answers. X equals 7 plus radical 11 over 2, because I've just divided out 2 from everything. And then x equals 7 minus radical 11 over 2. So there's our final answer with the 2 solutions here. They're both irrational because, of course, the square root of 11 is an irrational number. All right, so I think one more of these and we'll kind of call it quits for this first lesson, and then I'll post another one, later on, probably tomorrow or something like that, or maybe early tomorrow morning, we'll see. So let's FOIL this out first, and then we'll bring this 10x to the other side, because we need this to be equal to 0 in order to use the quadratic formula. So when we FOIL it, we get x squared plus 6x plus 5 is equal to 10x. And then we subtract 10x to both sides, we get x squared minus 4x plus 5 equals 0. And we can try to get this to be a factorable problem, but it's not, so we have no choice but to use the quadratic formula. So A is 1, B is -4, C is 5. So x equals the opposite of B plus or minus the square root of B squared minus 4AC over 2A. So again, we start to just simplify what we have. So this is 16. This is going to be minus 20 over 2 is equal to 4 plus -4 over 2. And the first thing that I notice now is that I have a negative underneath the square root, which means I'm going to have imaginary solutions here. I'm going to have complex solutions. So this will be 4 plus or minus 2i over 2. And at this point, we can start to split them up into 2 separate solutions and factor out all the 2's that are going out here. So this is 2 plus I, and so the x equals 2 plus I. X, I'm having a tough day today. X equals 2 minus I. Those are our 2 solutions there. All right, so again, we still got 2 solutions, 2 roots to these quadratic equations. This one just happens to be complex. All right, so thanks for tuning in again. Sorry for the late video. Hope that you get an opportunity to take a look at it prior to our Q&A session tomorrow. And if you have any questions, obviously, shoot me an email and hopefully I can answer them in a more one-on-one format. All right. Thank you very much.